exercising.
You look exhausted.
Yeah.
I think you need to drink some petroleum.
Petroleum? Are you kidding me?
Petroleum, commonly known as oil, it is the primary energy source for industry, which makes it gain the name the black gold. It is very important to produce many useful products like plastics and inks. Because of its significance in industry, it is also called the mother of all commodities.
According to the most accepted theory, biogenesis of petroleum, the initial step for formation of oil involves fixing atmospheric carbon dioxide using solar energy by photosynthesis in photosynthetic organisms, which include aerobic cyanobacteria, algae, phytoplankton, land plants, and some anaerobic bacteria. Carbon dioxide and water undergo a series of redox reactions. As a result, carbohydrates and oxygens are produced, and oxygen is oxidized, carbon is reduced. In preparation for photosynthesis, electrons in photosynthetic pigment are at lowest possible energy level, ground state. A photon strikes an electron, and the electron gains a specific amount of energy. The energy level of the electron, therefore, is raised to a higher one, which is called an excited state. Excited electrons are relayed by different kinds of molecules. The process is called electron transfer chain. Molecules received electrons are reduced and energized. Carbon is the final electron receptor and hence reduced. Overall, energy brought by electrons is used to establish the chemical bonds of carbohydrates, which will be eventually released when petroleum is used as fuel.
What are you doing? I'm transferring my electrons to you. I'm reduced, you're oxidized. I'm reduced agent, you're also an agent. Do you feel my energy?
Well, I feel electrocuted. Did we just undergo a redox reaction with transferring energy?
Knowledge on organic chemistry is critical to understand the transformation of carbohydrates into hydrocarbons, the key constituent of petroleum. Decomposed plants precipitate into soil and sediments containing them become burial. As the depth of burial increases, pressure and heat increases. Therefore, after millions of years, petroleum is formed and stored in the stratum.
Are you meditating?
Yes.
What are you meditating?
I want to become a carbon. Then I can experience the slow transformation process in producing petroleum.
Why do you want to be a carbon?
Because carbon is the key element in organic chemistry. I have 4 valence electrons, therefore it allows me to form single, double, and triple bonds with other molecules. Due to my unique bonding properties, I can form different variety of molecular structures. Different functional groups can attach to me, which gives me the unique chemical properties. Now I'm forming double bonds with another molecule, and we are alkene groups now.
Crazy man.
After living organisms die, the organic macromolecules are broken down to biopolymers, like proteins and carbohydrates. Biopolymers are then transformed into gel polymers called kerogen under the influence of geological interactions. This process requires sufficient geothermal pressure for sufficient geologic time. During this process, carbohydrate is transformed into hydrocarbon by isomerization and aromatization coupled with loss of oxygen and sulfur. Isomerization is a chemical process by which a compound is transformed into one of its isomeric forms, and aromatization is a conversion of cyclohexane into aromatic rings. Now what is followed is carriage and cracking, which liberates hydrocarbon. Finally, petroleum is formed. This can occur very quickly when the temperature is very high. The hydrocarbons released must migrate from the source rock to a suitable trap, where they can accumulate in a reservoir. The reservoir rock must let the petroleum to flow through so that it can accumulate a large amount of petroleum. The rock over the reservoir rock is a sealing rock. It has a low permeability for petroleum so that it can keep the petroleum within the rock. Now the petroleum is kept under the rock.
In the manufacturing process, there are three main processes: separation, conversion, and purification. First of all, the separation process takes place at first when crude oil is refined. The oil is separated into its constituents by distillation, and some of them are further separated by solubility. Different hydrocarbons have different boiling points. The mixture was heated and passed into a temperature gradient: low temperature at upper level and high temperature at lower level. Components of low boiling point aggregated at upper level and components of high boiling point aggregated at lower level, since the column is heated from the bottom. Like boiling point, the concentration of components of low boiling point increases as it goes up, and concentration of components of high boiling point increases as it goes down. In fact, the fractions rises highest in the column is called light fractions, and those condensed on the lowest are called heavy fractions. Therefore, by separating hydrocarbons into different types in order of volatility, light fractions, which are refinery gas, gasoline, kerosene, light and heavy oils, and finally, long residue, which is heavy fractions, they can be utilized for further treatment and blending. However, the refinery fuel gas contains hydrogen sulfide, which must be removed before the gas is burnt as fuel to prevent excessive sulfur oxides emissions. This is carried out by the reaction called ADIP process. As the diagram shows, by reacting the hydrogen sulfide with a solution of diisopropanolamine known as ADIP, hydrogen sulfide is removed, forming hydrogen sulfide ion. The forward reaction is exothermic and gas is absorbed. According to the Le Chatelier's principles, since the reaction is exothermic, lower temperature is used in order to shift the reaction to the right. Also, since hydrogen sulfide ion is a solution, the gas molecules on the left side are 2 moles, while on the right side there is only 1 mole of gas molecule. Therefore, carrying out the reaction in higher pressure, the reaction will shift to the right as well. After hydrogen sulfide is removed from the refinery fuel gas, the next main process, conversion, is carried out. Of the oil separated out from the original crude, refinery gas, gasoline, kerosene, light and heavy fractions, and long residue, only refinery gas with ADIP treated can be used as products. All the other require further treatment. Firstly, sulfur compounds must be removed by the step called desulfurization. Sulfur has to be removed because it can poison the catalyst used in catalytic reforming. Sulfur can be removed by reacting with hydrogen, forming hydrogen sulfide, which can be removed as a gas from the cooled liquid oil. This reaction is carried out at a pressure of about 20 atmospheres and a temperature of about 350 Celsius degree. The forward reaction is endothermic, but there's a problem. At a temperature required to cause a reaction to shift to the right at a fast rate, the hydrocarbons will be decomposed and carbon will be formed. Fortunately, the left side has 3 gaseous molecules, while the right side has only 2 gaseous molecules. Therefore, by increasing the pressure alone can let the reaction shift to the right without causing hydrocarbon to degenerate. Catalyst is a substance that does not participate in the reaction, but it accelerates the rate of reaction. It lowers the activation energy and therefore the reaction will be faster. For instance, if I'm a catalyst and his rate of reaction, and when I touch him, he can run faster. After sulfur is removed, catalytic reforming process can be carried out. The ring reforming of hydrocarbon and aromatizing are occurred. Their desirable reaction is endothermic, therefore temperature of 500 degree, where hydrocarbons are considered as in gaseous state, and 25 atmosphere pressures are used. As its name is catalytic reforming, catalyst, platinum, and rhenium are used. The reaction can be carried out much faster due to the lowering the activation energy in catalyst beds. The last main step is called purification process. The hydrogen sulfide gas, which was extracted from desulfurization, is converted into sulfur, which can be sold to fertilizer manufacturers. Hydrogen sulfide is combusted and product sulfur oxides will react with 2 moles of hydrogen sulfide to produce 3 moles of sulfur and 2 moles of water. As a result, 1 mole of hydrogen sulfide is converted to 1 mole of sulfur by reacting with oxygen to produce water as byproducts. This recovers 95% of the sulfur. Then the hydrogen used must be purified. Now they are ready to be used and sold.
Petroleum, the super drink to boost your energy. Take it, you'll be Superman.
Thank you.
Ha 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 ha.